Hello everyone, I'm happy to have you here. Today I'm going to talk about Tinylibs, which is a place for tiny and minimal libraries in Node.js and some other environments. Well, let's start with who am I? I'm the founder of Tinylibs and the manager of Pheno agency, which is an agency that I lately founded. So let's get into the motivations. Well, the first motivation that made me start this organization was that I really liked one of the Unix philosophies, which was they do one thing and do it well. I wanted some libraries that only do one thing and do that thing properly and don't overdo the APIs or increase the features unnecessarily. The second motivation is removing the bloat from the JavaScript package space because you can see we have so many polyfills, we have so many extra dependencies that we may not need on each package that we install in our project. And the third reason actually was making Vitest, which is a testing tool, as minimal and lightweight as possible. 2 years ago, when I started working on Vitest with the Vitest team, we wanted to decrease the bundle size, make it faster, and make it lightweight. So that's one of the reasons that I started Tinylibs and other Tinylibs packages. We just wanted to have a minimal API and just get the thing done. So let's talk about TinyPool. TinyPool is a minimal and tiny Node.js worker thread pool implementation. It is lightweight, it doesn't have any dependency, it does have support for isolation, which just helps you remove the memory state and you would have a safe environment, which is really useful for the testing tools like Vitest. It has a minimal API and it also supports the child process package in Node.js. So at any point you can just switch between worker thread and child process easily. I would appreciate if you just start the project. That would help me get some energy to just continue developing this project. So let's just start with an example. I just created the sandbox that I'm going to share with you, which I just installed TinyPool, TinyBench, and TinySpy, the other two libraries that I'm going to talk about soon. So let's start working on the example. Well, we just import the default export of TinyPool, which is the TinyPool class. I just call it pool, so I will simplify it for you. Let's start making a pool. So I say const pool is equal to a new pool class. There's a required option which called the file name, which we would give it the worker file that we're going to pass to the worker threads or child process package in Node.js. Well, let's just make a URL, and I already have a worker file called the worker.js, and we'll give it the base, which is the import meta URL, and we give it the href. So we already have the pool, and we can now just start passing tasks to the pool, and it will schedule it in the queue and start passing those tasks to the worker.js file. Let me show you the worker.js file, which is just a simple file that exports a default function. And that default function is would wait 10 milliseconds, so we would slow it down a bit, and everything we will pass it as an argument. It would just return us the argument. It doesn't do anything extra. So let me just make a tasks array, so I can just push the results here, the promises results here, so we can later just await them and use those results. Let me make a loop. Let I is equal to 0 and run that loop for 50 times maybe. So let's just run the tasks. So we start pushing the promises, which are the results that haven't been returned yet. So we would say just pool.run. Here's the API. It's so simple. You just bring the run function and pass it the argument that you want to pass the worker later. So I would say I would pass it the I, which is just a number between 0 to 49, and let me just console the tasks so we see what just happened. So you can see we just pushed 50 promises there, which are the results. One of the mistakes that I see people make in the thread pool management space is that when they start pushing the task or when they run the task, they just await it like straight away. But this actually would ignore the purpose of the thread pool manager. The reason is that uh, we need to do things asynchronously, like in parallelism, and not just wait for them one by one, which that will make the library useless at the end. So awaiting it would give us the proper results, but it's not the proper way. So I will show you how you can deal with this later if you want to get all of the results like in parallel. So let me see why this didn't just run. I saved the file. So you can see it just gave us the results, but as I said, it's not the proper way. Let me show you the proper way, which is using the promise.all function, which would await for all of the promises in an array. So let's just give it the tasks, and we can see the results again. Yes, it just returned the results, and we can see we have the results and we awaited for them in parallel. So that's the way you can await for the results and just push tasks to the queue. So this is TinyPool. It's just as simple as that, and it will make your life much easier because it just manages everything for you, and you just need to just push the task to the worker.js file or any worker file that you give to TinyPool. So let's go to TinyBench, the second library that I'm going to talk about today. TinyBench is a lightweight benchmarking library. It was inspired by benchmark.js and some other libraries, but they were old, and we just say let's make something new so we can add a benchmarking integration to Vitest. It has accurate timing support using HR time in Node.js and performance.now in other environments. It's platform agnostic, like you can use it in browser, in Node, in Dino, and other environments also. It also has an extendable API similar to TinyPool, because using the class that it provides, you can just write plugins and this kind of stuff that you may want to add extra functionality to the library. And it doesn't have any dependency at the end. So let's just have an example and start working with this library. So let me just remove the TinyPool instance and import from the TinyBench library. So we import the bench class, which helps us adding different benchmarks, so we can just start working with the instance that this class returns, and we can run the benchmarks and get the results. So let's say const bench is equal to a new bench, and you can just start adding tasks right away. So let's say we have a faster task here. And we add another one, which is a slow task, obviously. Here's the task for it. Let me just format the file so you can see it in a proper way. So here we have the faster task. We won't add anything to it. It's just a simple function that would get run by the benchmark. So we show that it's a faster one. But in the slower task, let's just make it async. and await for new promise, which would take like 10 milliseconds. So this line just would make the function wait for 10 milliseconds. So we actually make it a little bit slower. It's not a little bit, it's much slower, but I mean in millisecond sense. So let's not do anything extra and make it just that. So let's run the benchmarks here and await for them, since it's an asynchronous process. So let me save the file, and you can see one of the things about TinyBench is that it doesn't log any result by default. It just gives you control to everything, and you already have the task list here, so you can log that, or there's a better way. Let me just first log the tasks. So we just show the tasks array. You can see it's like, since it's bundled, like it show some weird result, but here's the better way. You can use the console.table and log using the bench.table function, which would give you the results in a table form. So let's save. So we have a faster task that it has 11 million of operations per second, and the slower task, which is 97. The first one is much faster, but we also have much more samples to calculate based on. So here are the results, and that's the way TinyBench works. It's really simple, and you have full control over everything. For instance, if you want to limit the samples to a certain amount for all of the tasks, you can just go to the options and write the iterations option, which I would say let's limit it to just 100 times. And let's see. You can see that at least it goes to 100 if it passes the limit time, which is 500 milliseconds. It would go to the 100, and for the faster one, it just keeps running until we reach a certain point. Or we can also limit based on time. Let's say a second. You can see it took a second to run both of the tasks, like each of the tasks takes 1 second. So here are the samples. Here's at the average time by nanoseconds, and here are the operations per second. The task name is also here, so you already have full control over everything. Like for more information, like I just put a complete documentation on the README file. You can go to the docs part and see all of the options and all of the methods and functions that you can use to get access to the results and control the result even. Next, we have TinySpy, which is a minimal fork of NanoSpy, but with more features, and at the same time, we've been able to keep it lightweight and minimal. I won't give an example for TinySpy since we don't have that much time, but TinySpy gives full access to all of the details of a function when we run it using TinySpy. We can also spy on objects, the getters and the setters, and it only has 2 APIs, so it's already minimal. Let me show you the documentation. So here's the documentation for TinySpy. It's only 10 kilobytes. You can run it in Vitest, JS, and also in the browser. So we can install it. We have 2 functions, the spy function and the spy on function. The spy function, we would use it for spying on a function. So you can see like we spy on FN, and when we run the FN using the spied instance, it keeps track of everything. Like we say, it's already been called, the call count was 1, the calls, the arguments were like an array of A, which is a list of arguments. It says the results returned and what it returns. You can reset the calls, returns, and everything in the spy. So let's just go to the spy on function, which would give you access to the objects that you spy on instead of just functions. So you can see here that we can spy on an object, and we spy on the get apples getter. So we return the apples here, and when we change the apples and we call it, it prints one. It's just simple, but at the same time it keeps track of all of those details. You can see different examples here. It's really simple and minimal at the same time. So that's it, folks. Thank you so much for giving the time, and thanks to the SFNode crowd for giving me the chance to talk about Tinylibs. I really appreciate it. Goodbye.